Hello, thank you for giving me the opportunity to talk about power integrations here at Electronica. Like most power supply companies and power IC companies, initially when we started working with India 25 years ago, we offered 750 volt transistors for India applications. In the last 15 years, we've gone from 750 volts. At the end of 2024, we finally moved to 1700 volt GaN devices. Now, all this GaN technology is developed by power integrations using a proprietary process. The process we use is called GaN, and it revolves around a cascade structure for the power switching device. And one of the things that power integrations does, it's in our name, is we provide integrated solutions. So one of the initial challenges with GaN for power conversion was allowing customers to utilize the technology without having to learn to drive a completely new switch type. What we do is integrate the driver, the GaN switching device, the control electronics, all in one of our ICs. And this makes it very easy for customers to start to use GaN and get the benefits of higher efficiency, and in India case specifically, the higher breakdown voltage, without having to go about learning about a whole new technology. This has made GaN very good for PI in India. One other thing I'd like to add. The voltage rating for GaN transistors is very different from silicon. Silicon devices, you have a voltage rating of maybe 725 or 750 volts. When you exceed that voltage by even a small amount, you start to damage the transistor. GaN devices do not work that way. They do not have the avalanche breakdown characteristic that you see with silicon. And although we say it's a 1700 volt rated device, you can stress the transistor to 24 or 2500 volts without damaging the device. You see a shift in its performance characteristics, but then migrate back to normal operation after a few hours. And what that means is GaN is extremely robust against line fluctuations and especially line surges. And that makes it really good for the India market.
Andrew, would you like to comment about silicon versus GaN?
Of course.
Would you?
Yes, absolutely. So at Power Integrations, there is always a debate about whether to use silicon or gallium nitride or even silicon carbide. All those switch technologies work very well in many applications. We believe that GaN will become the technology for power conversion in the future. But there is still a place for silicon. GaN switches are very small. And if you design a GaN switch for below 20 watts, the die size for that GaN switch becomes so small, it's very hard to manage in manufacturing. So below 20 watts, we don't think silicon is going away. We already have 900 volt silicon, and so there are applications that we see that continuing in. Where GaN will start to change the marketplace is at higher voltages. Silicon carbide is very, very good at 1700 volts or 2500 volts. Today, we see our silicon carbide competition as being competing with our 1700 volt GaN technology. Now, the interesting thing about that is silicon carbide is very good switch, but it's expensive. And that's because it takes a lot of energy to manufacture silicon carbide. GaN devices, and why I say GaN will replace silicon, fundamentally cost no more to manufacture than silicon. Now, at the moment, silicon has an advantage in price because silicon has had probably 75 years to reduce the cost of manufacturing. But as GaN starts to realize those benefits as well, and also gets to amortize the equipment necessary to manufacture GaN devices, we will see that the price of GaN starts to come down to match that of silicon. And in doing so, it will be very much lower cost than silicon carbide, which cannot scale its cost due to the high energy budget needed to manufacture it. So GaN will start to move into the space occupied today by silicon carbide. And that's really good news because you can bring down system cost while keeping the high reliability of silicon carbide and the very, very good efficiency that wide-bandgap semiconductors bring you. So the future we see is where GaN can go, GaN will go.
And my last question is, any message to your Indian clients, your Indian customers?
Sure. So at Power Integrations, we know how busy everybody is in an economy that's growing as fast as India's. We have a lot of tools on our website to help you design your power solution. We have a very wide range of different product families to match precisely which application you want to apply it to. But that itself can cause some challenges with which part do you use. Power Integrations has a lot of tools on its website. A design tool called PI Expert, which is a free download power supply design tool, which allows you to very accurately create a power supply design. We also have support services like our Power Pros, which are an online group of application engineers to help you with design. For any of that information, come and visit us on the web at power.com.